Alright, hopefully the first lesson on vectors went pretty smoothly. If not, please make sure that you get in contact with me. Either send me an email or send me a message on Schoology, and I'd be happy to help you out during the times I'm available. So this next section is continuing with vectors. We're actually just going to be working one of two ways. They're either going to give us the magnitude and the direction, and we're going to have to find the components, or they're going to give us the components, and we're going to have to figure out the magnitude and the direction. So the first type of problem we're looking at, they're giving us, pay special attention, this is a new symbol. I think I forgot to explain yesterday. But this symbol means magnitude. So if you see that it looks like double absolute value, that means that that is the magnitude. And then the theta is telling me the direction. So the first thing I need you to do is graph this vector. We're graphing it in the quadrant based on what the theta is. So you're going to always look at that first. That means it's going to be in the first quadrant, and this is going to be 50 degrees. And the magnitude should go on the hypotenuse always, so that 8 is going to go on the hypotenuse. And they want us to find the I and j components, which just means we're trying to find the horizontal component, x, and we're trying to find the vertical component, y. So we just need to find each of those components. You can do that just by looking at the triangle. It is a right triangle, so since it's a right triangle, I can use SOHCAHTOA. So to find x, x is adjacent and 8 is hypotenuse, so I can do cosine. It's going to be cosine of 50 is equal to x over 8. And then I just need to cross multiply and solve here. This is 8 times the cosine of 50 equal to x. And I'm typing that in my calculator, get an answer. You're going to round to 2 decimal places, please. And you should get 5.14. That's the x component. Whoops, I forgot a 1. 5.14. And then to get the y component, that's the opposite in hypotenuse. So we're going to use sine to find y. Sine of 50 is equal to y over 8. We're going to multiply the 8 over there on the other side. We're going to get y is equal to 8 times the sine of 50, which is 6.13. So then to answer the question, they do want it in terms of i's and j's. That's what it asked for up in the directions. So you're just going to put the horizontal one was x. That gets the, excuse me, the I part. And then the vertical one gets the j part. So that's your answer. The book walks through, gives you formulas to memorize, but I think if you just draw the picture, it's a lot easier to just get the answer. So looking at number 2, again, the first thing we're going to do is graph it. What's different with this one is this is in a different quadrant. This is 0, 90, 180, 270, 360. 335 is going to be somewhere in this 4th quadrant. So we're here, and I know that my theta, technically, it's that angle to go around, but you can still put the 335 inside of here. It's kind of weird to put it in a triangle, but we're going to use it in the formula in a second, because it will help you decide what's supposed to be positive or negative. And then the magnitude goes on the hypotenuse, and I need to find x, and I need to find y to be able to get the component form. So I'm looking for the 2 components, the horizontal piece and the vertical piece. So to find the horizontal piece, it's again cosine. Cosine of 335 is equal to x over 10, and then we're just multiplying by 10 on the other side. I'm going to type that in my calculator. 10 times the cosine of 335. And the nice thing about using that whole angle is it's going to give you the correct sign here. X should come out to be positive because we're going to the right. And then to find y, I'm using sine. Sine of 335 is equal to y over 10. And then I'm going to multiply by 10 on both sides to solve. 10 times the sine, 335. Notice this comes out to be negative. It's negative 4.23. Which should make sense because in the picture that component is moving down vertically, so it needs to come out to be negative. And then we're just putting it into component form with the i's and j's, so it's going to be 9.06i minus 4.23j, because that's the vertical component. Okay? Alright, the next set of directions, this is how it would be phrased in physics, is it says that they want you to resolve the vector in component form. So this still means you're still finding the horizontal and vertical pieces. It's just the physicsy way of writing it. So we want the horizontal and vertical components. They're also phrasing your magnitude a little bit differently, as they're giving you the force of it is 1,000 pounds or 100 pounds. This is just your magnitude here. This is another way of representing magnitude. So my direction, I need to make sure I graph it in the correct quadrant. That would be in the second quadrant. And I'm going to draw my triangle to the x-axis. I didn't say that in the last ones, but that's how you know where it goes. It should always connect back to the x-axis. That's 145. The hypotenuse is where the 100 goes. And I'm again finding x and y. To find x, same formula. Cosine of the angle is equal to x over 100. And then I'm timesing by 100. I get x is equal to negative 81.92. And then to find y, I have to do sine. So it's going to be sine of 145 is equal to y over 100. And then I'm going to multiply by 100. And I get y is equal to 57.36. So my component form would be negative 81.92i plus 57.36j. So that's my answer. Alright, now we're going to go the other direction. So now in these ones, they are giving you the component form. They're giving you the ij form. They want you to find the magnitude and the direction. So first thing I'm going to do is I'm going to graph it. These make a whole lot more sense visually. So this says that it's going to go over 6 and up 8. Those are my two components. The horizontal one is 6, the vertical one is 8. And we're looking for the magnitude and direction of this vector right here. So I need to know the magnitude, which would be the hypotenuse. So again, for the magnitude, we have the formula. The magnitude is equal to the square root of 6 squared plus 8 squared, which is square root of 36 plus 64. Get the square root of 100, which is 10. So that's my magnitude. Then I need to know the direction. The direction is actually the angle. So I need you to get that in your head. When it says direction, that means you're finding the angle. And this one's in the first quadrant, so it's going to be relatively easy, but I'm going to put theta in the picture. And if you look at the picture, we have opposite and adjacent as our two sides, so we're going to use tangent to help us find it. So it's going to be tangent of theta is equal to 8 over 6. And then to move the tangent to their side, I have to use the inverse. That's what I'm going to type in my calculator to find theta. And what you get for the angle should make sense for the quadrant that you're in. So this comes out to 53.13. Since I'm in the first quadrant, that makes sense. In the next example, you're going to see that we're in a different quadrant, and anytime you're in a different quadrant, you're going to have to think about what math you need to do to figure out what that angle would be to put it into the quadrant that you're in. But for this one, we can just leave it because we were in the first quadrant. Alright, let's try this one. So again, I'm going to graph it first. The horizontal component, we're over -4, and then the vertical component, we're down -2. This right now is what I need to find the magnitude of. The magnitude is just the hypotenuse, so it's the square root of -4 squared plus -2 squared, which is square root of 16 plus 4. We get the square root of 20. And then we're going to leave that in radical form for today. Well, that is not the answer in radical form. It is 2 radical 5. So that's your magnitude. And then we want to find the direction here. The direction is finding theta. It's again going to be tangent. Tangent of theta is equal to opposite -4 over adjacent -2 over adjacent -4. And we're going to do the inverse of that on my calculator. If you want to simplify it first, you can. I'm just typing it in. So it's the inverse of -2 divided by -4. You get 26.57 degrees. But here's the problem. That would not create an angle that's in the third quadrant, which is where we know that that vector is. So we have to think about what math we need to do to swing that all the way into the third quadrant. So that is actually past 180 degrees. So all you need to do is add on 180, and that will give you the angle that's in the third quadrant. But your goal is always to think about what can I do to the angle I got from the calculator to figure out what quadrant it would need to be in. So this is the angle, and that is actually something that's appropriate that would result in graphing that vector in the third quadrant. So usually it's going to be either adding or subtracting 180 or adding or subtracting 360, depending on which one you're closer to. So kind of think of it like reference angles in reverse. If you're closer to the 180 side, you're going to do something with 180. If you're closer to the 360 side, you're going to do something with 360. So there'll be one of these for you to try on the class kick along with an additional problem like the first set of problems that we did. And then you have a whole homework assignment to practice on this. It's a worksheet and the answers are already posted, so just make sure as you go through, check your answers, especially for these last problems that you're really thinking about how to get what that angle is, and then you'll mark the Google form and we'll go over questions from there. Alright, hopefully we are doing okay with the e-learning. Keep up the good work, and I will have another video for you guys tomorrow. Hang in there.